So in our previous lecture, we have learned about multiple transformation techniques on continuous time signal. Uh, these are the basic transformation techniques like time shifting, scaling. While there are two types of scaling, time scaling and amplitude scaling, and finally the time reversal. So ultimately what happens when we apply this transformation technique to our basic continuous time signal? Okay, so we have taken an example, right? Y of t, which is a modified signal of x of t. So this is a modified signal of x of t. So we need to recognize what are the transformations that we're using to modify y of t from x of t. Okay, let's see. First, as you can see here, there's an a magnitude is multiplied to the signal. Okay, this side of signal. So this is simply amplitude scaling. We have to multiply our total signal by a time. Okay, then if we see the signal modification here, x of, there's bracket, and there's two different transformation happening in between the bracket. One is simply, as you can see, this small a, which refers to our time scaling. Okay, and another one is our time shifting. Okay, as a constant is added here. Okay, there's one important transformation also happening here, that is time reversal. Okay, as we have seen that there is a negative minus of at, so you will need to do time reversal on this signal. So to get y of t, our modified signal, so we need to perform amplitude scaling, then time scaling, time shifting, and time reversal on x of t to finally get our y. So here, as you can see, I have modified the y of t a little bit. This will come in very handy for us. I recommend you also doing this. Okay, so there's nothing. I have just taken a minus a as common from this side, and finally got this equation minus a into t minus of t naught by a. Okay, now we're gonna see how I can get y of t from x of t. Okay, so basically here, as you can see, uh, I have written a process how we can get y of t or modify our x of t. So basically, you need to do firstly time reversal on x of t, which will be x of minus t. Okay, x of minus t. So this will proven to be our time reversal of x of t, which will reflect our x of t by the y-axis. Okay, then we're gonna do the time scaling, which will be which will depend on the value of a. If a is less than 1, the signal will be expanded. Okay. And if a is greater than 1, then the signal will simply compress. Okay, so this is our time scaling. Then we need to do time shifting. Here's a little bit tricky part, as we have shown there, we have taken minus a as common. This is necessary so that we won't be doing any kind of mistakes to transform our signals. So here, as you can see, we have shifted our signal by minus t by a. minus T naught by A, not by plus T naught or minus T naught. This is very important. Okay, so we have shifted our signal by minus T naught by A. So here, as we know already, that if T minus T naught we have seen, then the shifting will happen to the right side. Okay, and we happen to have T plus T naught by A, the shifting will happen in left side. So here, as our exam, as I have taken an example, our shifting for that example would be the right side by T naught by A. This is very important. Then finally, we have modified our basic signal. Then we need to do simply our amplitude scaling. Okay, simply our amplitude scaling, multiplying the signal A to simply the amplitude A, capital A, that is given. So there is a hierarchy of steps. So first we need to do time reversal. Then we need to simply do time scaling, either compress or expand. Then we need to do the third step, which is time shifting. Finally, we can do fourth step, our amplitude scaling. So in many of examples, you will see that someone try to do this differently, but I try to maintain this hierarchy because it is less hazardous, and you will likely to make mistakes, not very much. Okay, so thank you.